Warm up for lesson 5-4. Pause, and here are the answers. Pause, and here's the answer. Lesson 5-4, Analyzing Graphs of Polynomial Functions. Objective, graph polynomial functions and locate their zeros. Find the relative maximum and relative minima of polynomial functions. Let's take a look at this polynomial function, and I have already identified the turning points over here using the graphing calculator, and I've identified this other zero using the graphing calculator. So let's go ahead and answer these questions. Okay, a y-intercept is where the graph crosses the y-axis, and we know that x has to be 0 at this point. So when we look at the graph, we can see that y is also 0. The x-intercept is when y is 0. Now that's going to happen right here. This is both an x and y-intercept. And the other x-intercept is located right here, which I have found with my graphing calculator. Okay, let's go ahead and talk about domain and range. What can x be? X can be all real numbers, very similar to the parabola. And what is the range? Well, we can see we have negative values, but we have a top value over here at this turning point. So it'll be negative infinity to 8.67. Now let's talk about relative minimum. In this picture, we don't have a relative minimum. It would have to look something like this. It would have to be the smallest value in the neighborhood, and we don't have that. We do have a relative maximum over here. We have the highest point in this region right here. So we're going to write that down, the point 1.76, 8.67. This also happens to be the absolute max. In other words, there's no other y value that's larger. So it plays two roles here. Now let's talk about decreasing and increasing. Over here, if you were to take a skier and have him put his skis right on the slope of this hill, his skis would turn up because he would be going up, and then his skis right here would be turning up. If the ski is turning up, this is what we call increasing. And increasing is what we do when we look at the interval is we look at the x values where the y values are getting larger and larger. So increasing will go from negative infinity, and notice the skier's tips will go up until this maximum point, and the x value there is 1.76. So when we're talking about intervals, we're talking about the x's that go with these y's that are increasing. Now let's talk about a skier going downhill. So here's a skier, and then there's the tip of his skis, and you can see they're heading down. And when that's happening, then this is a decreasing idea because the y values are getting smaller and smaller. And what we would do is we would start from this x value of 1.76, in fact where we took off from here, and then we would continue until infinity. Now what this tells us is that all these x values from here to here, the y values are getting smaller and smaller. All right, let's take a look at this same picture and talk about a new idea. When I take a look at two x values, this x value and this x value, that's located right here and right here, I notice that the one y value is negative and one y value is positive, and it had to go through an intermediate value called 0. Intermediate means a value in between a negative and a positive, and that's what's happening right here. It also happens over here between these two x values. So between 2.5, which is right here, and 3 was way down here where we couldn't see it. Notice that these y values are going from positive to negative. So there must be an intermediate value, a y value between a positive and a negative, and that is 0. Now this idea of having a value between two other values, in fact what we're looking for is this 0 between two other x values, this idea is called the intermediate value theorem. All right, again, the intermediate value theorem states that when you have 2 points and the y value of one and the y value of the other change signs, and this is a polynomial, in other words, it's a smooth curve, then we know that between an intermediate value between negative and positive will be 0, or vice versa. Okay, which graph is the graph of this? Now I'm going to do this problem instead of letting you do it because I want to give you some hints on what you're looking for. First thing is, notice it's a cube, and with a cube we know that it looks similar to our parent function. Let's go ahead and draw the parent. The parent of x cubed looks something like this. And notice that its end behavior goes at the two extremes. So we know it's not this graph, and we know it's not this graph. So it must be one of these two. Now remember that this is a positive value, so it's going to emulate the parent function y equal to x cubed with its infinities. So as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity, and that takes place here. Maximum and minimum points, relative max and relative min. We were doing this on the graph. Now let's talk about it in more detail. A relative max right here, we say relative, in other words, in the neighborhood, not over the whole domain. That the function is the maximum for nearby points. So it has the greater y coordinate there. And the graph is usually increasing as it approaches A and decreasing as it moves away from A. Now relative minimum, like this, it means that in the neighborhood it's the lesser y value around nearby, which means it will be decreasing as it approaches B and then increasing as it moves away. And these are called extrema. These points are often referred to as turning points. If a figure has, it says if the polynomial has a degree n, it has at most n minus 1 turning points. What this is saying is if you have a degree of 2, and we know that degree of 2 either looks like this or looks like that, it's going to have 2 minus 1, which is at most 1 turning point. If it has a degree of 3, it might look like this, so this would be 3 minus 1. At most it'll have 2 turning points, and right here we have that. And so we can go on like that. Okay, let's take a look at a graph, and again, let's take a look at the idea of increasing and decreasing. All right, right here, this is called a relative maximum. And remember that when you're approaching the relative maximum, you're increasing before. Again, the idea of the skier tips are going up. But after the relative maximum, the skier's tips are pointing down. Here's a relative minimum. And again, the skier tips as it approaches are going down. But the skier's tips as we climb the mountain are going up like this. Okay, let's do this problem once again. It was similar to the one we did at the beginning of the screencast. Let's do it once more. X-intercept is when x is 0. And if I put 0 into this equation, I'm going to get a 3. So the y-intercept is 3. It's kind of hard to read. It's right around here. And the x-intercept is where it crosses the x-axis. So that means that'll be 0, comma, and we would have to find these points right here using our calculator, and that would be, there would be 3 of them. All right, the domain will be all real numbers, similar to the parabola, and the range will be what are the y values. We have very small values and very large, so it will also be all real numbers. Okay, relative minimum, I use a calculator to find that one, and that's going to be 2.90, negative 12.05. Relative maximum, I use a calculator to find that one. There are no absolute max or mins because these y values get larger or these y values get smaller. When is it decreasing? And remember, decreasing is the idea of the skier's tips pointing down. So we're going down the mountain. That will be from, remember, we're going to cite the x values, negative 0.23 to 2.90. These are the x values where the y values are getting smaller. The increasing will be negative infinity to negative 0.23, and then the skier's tips will be going up from 2.90 to infinity. Your turn. Pause and see if you can do the problem. And here's the answer. Let's take a look at a polynomial model and see what kind of information it can give us. So here's this information about admission to movies, and from 1926. So 10 years later it'll be 1936, and you can see there's a real peak in the admission. This is around 1976, and it looks like that's a real low. And in 2001 it looks like it picked up a little bit. So what trends in movie admissions does this suggest? And what I was just saying is the trends that I saw. Is it reasonable that the trend will continue indefinitely? So will it continue to go down? We don't know. We know what's happening between 0 and 2006, but we really don't have any idea what's going to happen there. All right, let's check your progress. Let's take a look at another real-life polynomial that represents inches in rainfall since March 1st. So the next month, that will be April, May, and so on. Describe the turning points of the graph and its behavior. Well, it looks like it's from March 1st, it'll be increasing the rainfall, and around between May and June, it'll reach its peak, and then it'll start decreasing after that in this 7th-month period. What trends in the amount of rainfall received by the town does the graph suggest? Well, it suggests that it gets its most rainfall between May and June. So the rainy season is between April probably to June, where they get a lot of rain. And the last question, is it reasonable to assume that the trend will continue indefinitely? Well, will they continue to lose rain for, to infinity? No. Remember that we have cycles in the year, so we expect that after 12 months the cycle will probably repeat.